Today we talk about inverse trig functions, and you did a little bit of inverse work last year in geometry. We'll try to explore that a little bit more today and add some new variations to it. So last year you were given that the cosine of an angle was equal to some number, and in this case we're going to call it root 2 over 2. And we've seen that on our unit circle over here. To find the angle, if you remember last year, you took the inverse of that number to get the angle. All right. So in other words, the inverse of a number is equal to some angle measure. Another name for the inverse of whatever the value is called an arc cosine, also called inverse cosine. And that's equal to the angle. Now, if I look at the graph or the unit circle and find a cosine value of root 2 over 2, that's asking basically where is x root 2 over 2. And I look and there's one here, and I look and that's a negative root 2 over 2, so that's not going to work, and there's another one here. So in theory there are going to be two values where x is root 2 over 2, and that in this case is pi over 4 and 7 pi over 4. And that would be my answer for a problem like this as far as you know to this point, if we were in terms of 0 to 2 pi. Now, to go a little bit more in depth, we're going to take and continue this discussion as though we're just looking at the unit circle and we're looking between 0 and theta and 2 pi. So if I want to know where the cosecant is equal to 2, well, the cosecant's the reciprocal of sine, so I basically want to know where sine is equal to a half. And that's basically where is y, angle theta, where y equals a half. And I go look at my unit circle and I say, well, y is a half right here, and then y is a half here, and then I've got negatives for y, so no big deal. So in this case, between 0 and 2 pi, I've got values of pi over 6 and 5 pi over 6. And those are the values on the unit circle where that happens. Tangent's a little bit different because tangent we know is y over x or sine over cosine. So I want to know where y over x is root 3. In other words, where is y root 3 over 2 and x equal a half, because that reduces to root 3. Now, in this case, I want to know where y is root 3 over 2 and x is a half. So that's here at pi over 3. But I now also know that if y were negative root 3 over 2 and y is equal to negative half, I also get root 3. So that also happens right here at 4 pi over 3. So I say at pi over 3 and 4 pi over 3. So to go even further with this, we're going to look at the graphs of the inverse trig functions now. So instead of graphing x's and y's, we're graphing, basically, we know that inverses switch the x's and y's. So if you'll notice on these axes, I now have angles going up and down and values going sideways. Once again, values sideways, angles up and down, etc. So you'll notice at sine I have a 0 angle and a 0 value. Now, at a pi over 2 angle, I have a value of 1. At a pi angle, I have a value of 0, etc., etc. So these are graphed in an inverse way, where I have the x values really on the y-axis and the y values really on the x-axis. And you'll notice that in each of these graphs for inverse sine, inverse cosine, and inverse tangent, None of these graphs are actual functions. And I said we're going to graph the inverse functions. Well, these are graphs of inverses, but they aren't functions because they don't pass a vertical line test. So in order to make them functions, we've got to limit their domain or change the possible x values that we can use. So to do that, we basically take and start drawing the graph from 0. And note that when I do my sine graph, I only get as far as pi over 2 before it starts coming down and then not passing the vertical line test. So I get as far as pi over 2, but then I have to go backwards to get to another area that can be graphed without failing the vertical line test. Therefore, the domain or the possible x values of an inverse sine go from negative 1 to 1, but the range is negative pi over 2 to pi over 2. That's as far as I can graph that inverse function. Likewise for cosine, if I start at 0, I can keep going until I reach pi, because then at pi it's going to come back down and around and not pass the vertical line test. So again, my domain is between 1 and negative 1, but my range goes from 0 to pi. Finally, for the tangent, we can go to pi over 2 before we get to an asymptote, so then I have to go backwards, okay, to negative pi over 2 to get to another asymptote, because it goes undefined at an x value of pi over 2. Therefore, the range for this is negative pi over 2 to pi over 2, just like for sine. Cosine is from 0 to pi. So given these limited domains, this introduces a concept called principal values, or the defined output values for inverse functions with those limited domains. And as seen in those previous graphs, so given the limited domains in the graphs on the previous slide, this introduces a new concept called principal values, or those defined output values for inverse trig functions with these limited domains. And you can see, just like in the previous slide, that the values that we answer for negative sine are from negative pi over 2 to pi over 2. For cosine, it's from 0 to pi, and for inverse tangent, it's from negative pi over 2 to pi over 2. And the capital letters notate that you are talking about principal values. If it's small case, we'll deal with that in another moment. So if I want to find the exact value of the expressions, in other words, find the inverse sine of root 3 over 2, and we're going to do this without a calculator, you have to know your unit circle. And because this is a capital, basically what I'm looking to do is I'm looking for values in this region right here. So from negative pi over 2 to pi over 2 that have a y value of root 3 over 2. Well, now that's only going to give us one value. In the whole unit circle, we could find two values. But in this stated region, there's only one place where I have a positive y value, and that's up here somewhere. And we know that at pi over 3, the y value equals root 3 over 2. So pi over 3 is my angular answer. For tangent, again, we need a y over x equaling a negative 1. And tangent has that same region to answer within as sine. But if we're going to get a y over x value of negative 1, then these two values, y and x, must be the same. And we must get a negative answer, which means our answer has to be down here somewhere, because I have a positive and a negative value. And the only place where I have a positive and a negative value is at negative pi over 4 Or what you guys might be looking at is 7 pi over 4 on your unit circles. But we have to answer between a negative pi over 2 and a pi over 2. And 7 pi over 4 is, in theory, while it's a coterminal angle to negative pi over 4, it is more than pi over 2 and can't be used as a principal value. So these next two examples are a little different in that I have two functions happening at once. They want me to find the inverse cosine first, followed by the sine, and in this problem the inverse sine first, and then find the tangent after that. Now the problem is, when I'm asked to find the inverse cosine or the inverse sine, the two values they're asking me to find the inverses for are not unit circle numbers. So I personally don't know what these values are right now. And the problem also is asked, well, hey, use a calculator to get that done. Because if I say, hey, tell me the angle where the x value is 5/7, at this point I don't know. I'm going to show you a trick after we do these with the calculator, how to do it without a calculator. But let's do first things first. So let's use our calculator. Pop that up. And on your calculator, basically what we're going to do is we're going to go ahead and make sure your home page is clear. And then you're going to make sure your mode is in the proper mode. And we're going to look to be in degree mode. If you're not in degree mode, cursor down, move over, highlight the degree, and then quit, and you'll be in degree mode. So now what we want to do is we want to take and find the inverse cosine. So second cosine, this is just like in geometry, 5/7, and it'll spit out an answer, which is about 44.4 degrees. And then we're going to find the sine of that. So sine of that answer, second answer, equals 0.6998. So roughly, if we round to the hundredth, that's about 0.7. So next, we'll take and find the inverse sine of negative 4/13 and then take the tangent of that using the calculator. So here we go. We've got the inverse sine. Let's try to keep this from blowing up. Inverse sine, second sine of negative, and I usually go parentheses 4/13. You can do whatever you want, I think. Just in a habit of doing that. And then I'll hit enter on that. It gives me an angle measure of about negative 17 degrees, which makes sense because it has to be between negative pi over 2 and pi over 2, and we're in degrees, so that's negative 90 and 90. And then I'm going to take the tangent of that, second tangent, the answer, and that gives me about negative 0.32. So as I told you before, we can also take and do these without a calculator. We just have to look at it in a different way. So both, again, I have the same type of problem. I have numbers that aren't unit circle numbers, but I'm going to use a calculator to do this. So listen to the way I'm expressing this. I need to find an angle whose tangent value is 3/5, or whose y over x value is 3/5. Well, I'm looking for something in the first quadrant because I know that's the only way I get an inverse tangent that's both positive. And I'm looking for some angle, which I don't know. And I'm never going to know unless I used a calculator. But I'm going to bypass that. I do know that the y value has to be 3 and the x value has to be 5. And then once I've found that angle, which I never will, then I have to find the cosine of that, which is just the adjacent over the hypotenuse. Now, I have the adjacent value. If I had the hypotenuse, I could get this problem done. So watch what I do here. I will say this is going to be some theta, and this is the triangle that would have that theta in it. A Pythagorean calculation gets me 9 plus 25 square rooted, or the square root of 34. So now notice I'm asked to find the cosine of that angle. Cosine of that angle is equal to the adjacent, which is 5, over the hypotenuse, which is root 34. Rationalizing, I get root 34 over root 34. And my answer is 5 root 34 over 34. And that's an exact value. It's not actually an approximation like we had before. I can do the same for this as well. It says I need to find a cosine, inverse cosine of 2/9. Well, I'm never going to find that angle unless I use an approximation from a calculator. But I do know that the adjacent over the hypotenuse is 2 and 9. So in that case, I know 2 is my adjacent, 9 is my hypotenuse, and I can find the y value because I'm going to need that in order to get the sine. So I have basically 81 equals y squared plus 4. So I know that 77 is equal to y squared, and y is equal to the square root of 77. Therefore, if I want to find the sine of whatever angle theta is, which I don't know, I need that y over the r value. And in this case, that's root 77 over 9. Lastly, this is more of a geometry style problem. So it says you've got a commercial airline plane flies at an altitude of about 10 kilometers. So I'm going to take and make this 10 perpendicular to the ground. Pilot starts descending towards the airport, and that's going to look something like this. If the pilot starts descending when the plane is at a horizontal distance of 300 away, what angle will the plane's path make with the horizontal? Well, here's the horizontal here, or you could say the horizontal's here. Doesn't really matter. It's the same angle because they're alternate interior angles of parallel lines. Well, if I want to find that angle, I know the tan of that angle, and I'm using tan because I have the opposite and the adjacent, is equal to 10 over 300. So now, if I want theta, I just take the inverse tan of 10 over 300. And then I can use a calculator to approximate that to the hundredth. And it turns out that theta is about 1.9 degrees. Let's do one more. 20-foot wires attached to a fence, put into the ground about 6 feet away from that fence to help stabilize it. So let's assume that that fence is here, 20-foot wire here. Assume that the fence is perpendicular and it's put into the ground 6 feet away. We want to know what angle does that wire make with the ground. Now in this case, we aren't given the opposite, we're given the hypotenuse. And the x value, or the adjacent value, that's cosine of theta is equal to adjacent 6 over the hypotenuse of 20. We're going to find theta by taking the inverse cosine of, what is that, 3/10. Pop that into the calculator. And we end up with about 72.5 degrees. And that pretty much takes care of inverse trig functions.